When are two propositions logically equivalent? The two propositions P and Q, which are given, are said to be logically equivalent, written in the form P is equivalent to Q if and only if the truth table of their bicondition, if P then Q and vice versa, has tautology, which means it's always true. So when we find that the bicondition of P and Q, if P then Q and vice versa, has a truth table which has tautology, where it's always true, we'll conclude that the two propositions are logically equivalent. Example show that the negation of P and Q is equivalent to the negation of P or negation of Q. We are going to show that they are logically equivalent. So remember that the propositions, now we are given these ones, negation of P and Q will be equivalent to negation of P or negation of Q when the truth table, if and only if the truth table of negation of P and Q, the bicondition of two propositions, negation of P and Q and negation of P or negation of Q, has what we call tautology, which means it's always true. Now we are going to show them by using or by making the truth table of this. If negation of P and Q, then negation of P or negation of Q and vice versa. So let's show them in the truth table. We have the two key propositions P and Q. So the truth table P, Q, negation of P, negation of Q, P and Q, negation of P and Q, negation of P and Q. Now, negation of P or negation of Q, then negation of P and Q. If negation of P and Q, then negation of P or negation of Q and vice versa. Now the truth table. The truth table. Yeah. So we have propositions P and Q. So you understand that we have two propositions. So the truth values, the number of truth values is equal to 2 power the number of propositions. So here will be 2 power 2, which is equal to 4. Now we'll have a 2 t and t, and then f. So for q we'll have t, then f, t, f. So negation of p will have f, here f, then t, t. Negation of q will have f, then t, f, then t. So p and q, the conjunction p and q, t and t will give t, and then here is f, also f, and then f. Now their negation of p and q is negation of this one. So here we'll have f, t, then t, and t. Then negation of p or negation of q, negation of p or negation of q. Here f or f will give f. Then here is t, because we are making this disjunction. Then here is t, and then here is t. Yeah. Then let's make now the bicondition of this one and this one. If negation of p and q, then negation of p or negation of q, and vice versa. So here f will give t, then here is t, here t, and then t. So after making the truth table, now our truth table is done. So if the bicondition of the two propositions has the truth table which has tautology, means always true. You see, there is no f. Now it's tautology. We conclude that the propositions which we were given are now logically equivalent. So it's proved that negation of p and q is logically equivalent to negation of p or negation of q, since the truth table of their bicondition now is tautology, where we see that it contains only truth values which is true, or simply it's always true.